Okay, for question number 35th, part A, we have to show that the following lines do not intersect each other. So if the lines do not intersect each other, that means there is some distance between them. If they do not intersect each other, so that means they are parallel and there is a distance between them. And if somehow they intersect each other, so that means the shortest distance between them should be equal to zero because they are intersecting at the point. And to find the shortest distance of two lines in the Cartesian form, it's the formula is x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, that are the ratios of the first line, a2, b2, c2, the Isolation ratio of the second line, the shortest distance, and take the determinant of that into this is VC and BC, CA and CA, and then AB and AB. So let's write 1, 2, 2, 1, 1, 2, 2, 1, 1, 2, and 2, 1, and square of these, okay, and under root. Okay, this is the shortest distance and this should not be equal to zero. So if this is equal to zero, that means the lines intersect. And if this is not equal to zero, that means the lines do not intersect each other. So x2 and x1 are the, so here x2 is the point through which this line passes, which is -2. If I write this in the standard form, let me write this in the standard form. The first one is x minus 1 by 3. Second one would be x minus of minus 1 by 2 and z minus 1 by 5. So here this line passes through the point. This is 1, -1 and 1. 1, -1 and 1. These are our x1, y1 and z1. So this is uh, x1, y1 and z1. Okay, for the second equation is x minus of minus 2 by 4 is equal to y minus 1 by 3 is equal to z minus of minus 1 by -2. And here the values point through which it pass is -2, 1 and -1. So this is x2, y2 and z2. Okay, let's put in the values of x2 minus x1. So x2 minus x1, -2, -1 is -3. This is 1 minus of minus 1 is 2. X2 minus y2 minus z2 minus z1 is -2. So -3, 2 and -2. Now a1, b1 and c1 are, these are the a1, b1 and c1, 3, 2 and 5. So 3, 2 and 5. And these are a2, b2 and c2, 4, 3, -2. So 4, 3 and -2. We have to find the determinant of this. And this has to be divided by b1. So a1, b1, this is b1 is 2 into c2. a1, b1, c1, this is c2, -2 minus b2 is 3 into c1 is 5 the whole square plus. Okay, so 2 into -2, -5 into 3, and then it's 3 into -2. Replace, put in the values, minus 4 into 5 the whole square, and then plus 3 into 3. I'm just putting in the values, the whole square. Okay, let's find out the determinant of this one. So this one is, let's evaluate it along first rows, the positive, negative, and positive. So -3, and the determinant we are left with is 2, 5, 3, and a -2, then -2, and determinant we are left with is 3, 5, 4, -2, then -2, and then 3, 2, 4, and 3. Okay, divided by, this is 2 into, this is -4, -15, the whole square plus -6, -20, the whole square plus 9 minus 8, the whole square. Okay, so which finally comes out to be, okay, this is Now -3 into -4 minus -15, -2, -6 minus 20, -2, 9 minus 8. And this is under root, sorry. This is under root. This is also under root. And this is -19 the whole square plus -20 the whole square plus 9 minus 8 1 the whole square, which gives me -3 into -19 minus 2, -26 minus 2 and 1 upon. Now 19 square is 361 plus 26 square is 676 plus 3 into -6, -6 and -20. Okay, and 1 square is 1. Okay, now 19 into 3 is 57 plus 52 minus 2. This is under root, and if I add them 6, 7 and 8, and then it's 7, 6, 13, and then 13, 69 and 110. So 1038. So 57 plus 52. So this is 50, which is 117 upon 1038, which is not equal to 0. So this is the distance. So that means the lines will, so there is some distance between the lines, which is the shortest distance. So lines will never intersect each other.